Okay, so today we have something that I think is kind of interesting on offer. We're going to do surface area and volume problems where we are working with three-dimensional shapes. So our first question, we'll start with an easier one. A rectangular box measures 8 by 5 by 3. What is its volume? Okay, uh, so here's the skeleton key for volume questions. It's always the area of the base times the height. Okay, so it's actually just the numbers they gave you multiplied together, 8 by 5 by 3. That's literally what you multiply. So 8 times 5 times 3 is 120. Or if you want to break it down and have one extra step, you could go to the step of isolating the base. That's 8 times 5, that's 40, and then 40 times 3, if that helps you think about the steps. But in any case, that's answer B. Always, 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 it's the base times the height. That is what gives you the volume. Question 2 is a little trickier, and it involves surface area. Okay, and we're going to look at a cube in this case and keep it simple. So we have a cube, and it has edges of with a length of 4. What then is the cube's surface area? Okay, so here's what you need to remember. When it comes to surface area, it is about counting and combining faces. Okay, so in this case, we're lucky. It's a simple situation because we're dealing with a cube. We only have to find the area of one face, and then that will apply to all the other faces as well. So we're going to take one edge, that's 4, times 4, and that gives us 16. Okay. And a cube has 6 identical faces, so you can add 16 together 6 times, or simply just multiply it by 6, and that gives you 96. 6 times 16 is 96. Now, again, the cube is a little simpler because all of its faces are identical, and you will encounter other kinds of shapes that do not have such an easy or uniform way of stretching that surface area out. But what you need to remember is just find, if you have, say, a very strange shape with all sorts of different kinds of surface areas mixed and matched, you just find the different surface area for each one of the surfaces, and then you add them. Okay, so you could have it, in theory, a very strange shape with, a circle or a triangle or with a square, whatever. As long as you find the individual surface areas and you add them together, that's how you find the total surface area. Okay, now the ACT actually isn't going to throw something that tricky at you, but the principle is, again, find the area and then add the areas, combine the total areas across the whole shape. Okay, so what does that lead us to? Well, again, coming back to the actual question, that's answer C. C is 96. And the trap was 64, which is the volume of the cube, not the surface area. Okay. All right, on to question 3 now. And we have a cylinder, the famous can of soup shape. It has a radius of 3 and a height of 10. What is its volume expressed in terms of pi? So the same master rule applies as in question 1. We want the area of the base multiplied by the height. So what's the base of the cylinder? Well, the base of a cylinder is a circle, so it's going to be the area, which is pi r squared. Pi times 3 squared is 9 pi. Now multiply that by the height, which is 10, and you get 90 pi. So that's answer C. Now, were you at all tempted to take 360 pi? If so, that's because you fell for the trap, which comes from using the diameter for the area of the base, which is 6 instead of the radius. That's a common ACT distractor, so watch out for that. Okay, let's wrap with something that's a little trickier. So we've got a fish tank here. The fish tank is 60 centimeters long, it's 30 centimeters wide, and it's 40 centimeters tall. It's filled with water to a depth of 30 centimeters. What is the volume of air in the tank? Okay, so we got to be careful. We're actually dealing with kind of 3 different depths here that we have to pay attention to. The tank itself is 40 centimeters tall, but the water only comes up to 30. And the question is actually asking you about that leftover space where the water doesn't reach in the tank. So let's make sure we're using the right dimensions that the question actually wants to know about. So the volume of water is 60 times 30 times, well, what? Well, it's the depth of the tank minus the depth of the water. That's going to give us the leftover area on top, which is 10 centimeters. So we really want 60 times 30 times 10, which comes out to 18,000 cubic centimeters, which is answer D. So what you have to do in this question is to watch out for the multiple traps that expect you to plug the wrong depth number into your equation. Watch out for that, and you're going to be just fine.